Hi all. So I'm Remi Sussan. I'm a journalist at thematic, which is the media of the FING. So I'm also a member of the FING. I'm not a scientist. I'm just fascinated by all these fields of synthetic biology, nanotechnology, artificial intelligence. So I am a complete amateur, and I will try now to make you understand why a group like FING, which is in digital computers, is so interested in synthetic biology. What is the relationship between synthetic biology, life, and computers? Something is happening, perhaps? Okay. Everything is against me. So, what is the relationship between the two fields? I think there are several points which are important to see. First, both technologies, synthetic biology and computer, have the same kind of development. They are quick. A few years, they become very powerful. They can be both open source. They can be both act. You can be a biohacker, or you can be more classically a computer hacker. So this is the first point. The second point, which is important, is that they are both what a writer named Stewart Grant called autocatalytic technologies. What is an autocatalytic technology? Yeah, that's great. Technology is great. Autocatalytic technologies, they are technologies which make all technologies progress. Stewart Grant says, for instance, that if you design a new motor for a car, this won't help you in buildings or in other technologies. But there are three technologies which are autocatalytic, according to Brown. This is infotech, computers. This is biotech, and this is nanotech. Nanotech and biotech are more and more merging in a new field, which is bio-nanotechnology. So we can say that the two autocatalytic technologies are infotech and biotech. That's the second point. And the third point is that they use both. We saw that with Alexandra. You have a slide with a short program. They use the same algorithmic process, and frequently they ask the same questions. So, the first thing to see is we say that computer science and biotechnology share the same very quick development. What is important in computer is that in the 50s, it was very, very expensive to have a computer. I think that the director of IBM who says that only a few computers will be necessary for all the United States in the 50s. So you imagine now everything is a computer almost. Can this be the same thing for biotechnology? Can the price fall down so much that everybody here, not only here because you are all specialists, but some guys like me who don't know a lot about neither biology, neither biotechnology, will be able to use biotechnology, like we use computer every day, and sometimes computer even works. So, you see, what you see here is a machine called OpenPCR. So I think most of you know what is a PCR machine, much more than I do. As far as I know, a PCR machine has for goal to amplify DNA in order to examine and manipulate it. You will correct me if I'm wrong, because I'm just, as I said, pure amateur. It's very expensive, of course, to have this kind of machine. This one is around $300, I think, something like that. It's built with raw materials. It's connected to a Macintosh with an Arduino. And it has been created online by an online community called dybio.org, doityourselfbiology.org. This is a new field, people who are trying to do garage biotechnology, as it's frequently called, or biopunk, or biohacking, or do-it-yourself biotechnology. So this community, which is international, is trying to do biotechnology by their own means, without a lot of money. And this is now possible because, as I said, the price are training. This is called the Carlson curve from Rob Carlson. You all know the Moore law. Moore law, the price of the computer are falling. According to Carlson, almost the DNA sequencing and synthesis are now becoming cheaper and cheaper in the same line of Moore law. As you see, sequencing is falling very quickly. Synthesizing, writing DNA is much slower, but it is falling down too. So you can imagine, no, really, garage biotechnology. Is this useful? Most of the biotechnology, the do-it-yourself biotechnology, is about learning, having fun, so on. But there are some really important applications. I will tell you the story of a girl who was one of the first biopunk or garage biotechnologists, whose father had genetic illness. She was an American, and as you know, in America you don't have always free access to medication and tests. It can be very expensive if you have a bad insurance. And she couldn't know if she was or not, I don't know the word, she was wearing the gene for this illness, and she built herself her own test. So this is an example of people who have got money and use do-it-yourself biotechnology in order to do something for their health. There are some biopunks. I use the term because I have a bad English, so do-it-yourself biotechnology, I will always make mistakes about it, so biopunk is important. There are some biopunks who are working for themselves, and some of them are in biohack lab or biofab lab. It is like fab lab for buildings or hackerspace for computer scientists. There are a few, quite a big number in the world, and there is even one in Paris, which is called La Paillasse. I am a very, very low UV member of La Paillasse, but as I said, I am not a scientist, so I just look what the others are doing. I don't know if there are some people from La Paillasse here, some members. I think well, okay. So La Paillasse was created 2 years ago, I think. And it was most of the time until now in Vitry with the TMP lab. I cannot tell much more, but there are strong chance that it will be in the center of Paris in the next following days. Here are some examples of projects from La Paillasse. There is a bioreactor. Again, when I enter in technical details, don't hesitate to correct me, which is used for culture of microorganisms. And the bioreactor of La Paillasse just had a dotation from a foundation named Space Gambit, which is funded by the NASA, I think, about a new device for space colonization. There is a transilluminator. It's very mystical with this work. Just a way to look at DNA when it has been amplified. And the transilluminator from La Paillasse is around 20 euros. I think it's more than 20 times less than the real price. There is a glove box. It's a kind of device with you can manipulate in a sterile environment some cultures. And they did one for €300. There is a big project of bacterial ink. You create your own ink, which is ecological with bacteria. There are some objects made from bacterial cellulose and kombucha. You talked about it a few minutes ago, and I think perhaps we will see some of objects in the cellulose.
I have some samples, but not this afternoon. Yeah, this afternoon.
Yeah, we will show them.
Okay. And there is also a project of biodegradable electronics, which is in partnership with some Sony engineers. It's about some device, some electronic circuits, which will be able to be biodegradable. There are also some workshops. For instance, there is frequently, and never saw one, unfortunately, a barcoding workshop. People come, I don't know if you went to some, and they see what there is in some food. They analyze the DNA of the food. Somebody told me that they analyzed the DNA of some canned food, lasagnas, I think, lasagnas, and they didn't even found DNA inside. So I let you imagine what kind of food it is. And I think that the technique of DNA barcoding is around €3 for an analysis. Very, very low cost. So you will say, and everybody says that, wow, you put biotechnology in the hand of newbies like me. We will build some Ebola virus and things like that as soon as we know. So this is a big question, a big risk. So there is right now a pronounce it. Do-it-yourself code of ethics, which has been made by various biohacker about transparency. Everything is open source, always. Safety, of course, also. Open access, citizen science, as Ariel told you about. Education, modesty, community, and so on. I know that some cynics among you will say that no charts of ethics has ever protected somebody to do some evil things. But the only thing I can say is that Al-Qaeda, mafias, states don't need biohacker states to do dangerous things. They have the money to build big material, and they don't need biohacker states. So I don't think the danger will come from biohacker states. Now, let's see the other part, which is the algorithmic process. Long before synthetic biology, there was a field called artificial life. Artificial life was exactly the contrary of synthetic biology. Synthetic biology is about creating, using the methods of computers to create living things. Artificial life was to create life in silico, as it was said, creating pure digital form of life. It's a little like the question you asked about going from dead to alive. The question was, is a digital form of life a simulation of life or a real life? So there was a lot of work about this. Here you see something called the long-term loop. It's what is called a cellular automaton, which is able to reproduce itself. There was a lot of buzz around artificial life in the 90s. There was even a game called Creatures. Perhaps some of you have played with Creatures. At least one, I see. And Creatures was both a game and an experiment in artificial life. So you have little cute creatures called the nodes, and they have a DNA, they have a little neural network, and they go in their virtual world, and they reproduced, and there was some genetic algorithm, and of course the children were different, and hopefully so more intelligent than their parents. Most of the time they were not. That's another story. There is a legend about it that a woman from Bondi went to see creatures when it was not even in the commerce, and she says that, wow, what a great idea. And she came back to Japan and they created Tamagotchis from it. This is a legend, I don't know if it's true. But there is something really important in artificial life. I think it's a little about your question about directed evolution. Artificial life was seeking, I say was because the field is really right now quite dormant, was seeking to create complexity and emergent property. They were seeking something which cannot be predicted. They hope to see something surprising come. On the contrary, synthetic biology is engineering. You want to know what you are creating, so that emergent property doesn't come. Drew Andy, who is one of the big thinkers in synthetic biology, said, I hate emergent property. When I take the plane, I don't want the plane to have emergent property. I want it to go from A to B. And so there is quite a different goal and philosophy beyond the two technologies. See, here you have an example of a software of synthetic biology called Genome Compiler. It's a way to, it's a reverse of artificial life. You use a computer, a kind of CAO, CAD software, in order to create new molecules, new pathways in synthetic biology. The creator of Genome Compiler and many people from the synthetic biology field say that with this kind of computer approach, tomorrow you will not have to be a biologist to create new kind of life. You can be somebody who don't know how to use it, but you can do it in the same way that you use a high-level language in computer without knowing the working of the computer. You know, in the 50s, people were working with computers. They worked on the hardware. When they wanted to do a program, they used the lamp and things like that. Then they create higher language, machine language, with 0 and 1. Then assembly language, a little more complex. And today, when you are doing your blog, you don't ask yourself how the computer is doing, just write. So one day, they say, with software like that, we will be able to create all form of life by yourself. I tested for you all the software. I am the perfect guy to test it because I don't know anything about synthetic biology. 50% of the software I found on the web were dead. No more. 404 error. Some of them were not working. There is a Microsoft program about doing synthetic biology with a nice tutorial. I did the tutorial and nothing worked. That's Microsoft for you. I tried this one. This one was very seductive, but each time I click on a button, they say, in the next version, you will have this button. Like Pluto, I downloaded it. I didn't even know to start it. It's very mysterious, a lot of icons in every part of the screen. And no more screen. Okay.
Could you speak about Microsoft?
This one is Sony. Okay, so you see there are two different philosophies. Can we do a synthesis, not of biology, but of the two philosophies? There are some attempts. For instance, this is called an evolution machine. It has been created by the Georgia Church in Harvard. We will speak about Georgia Church later. It's a kind of machine which will try to do directed evolution, in fact. It's writing DNA sequence in parallel, thousands and thousands combination of DNA sequence. And after, the big task is not to create all this sequence, but to find the good one. So it's another approach. But they try to create complexities, in fact. They don't try to reduce complexity, they try to create it and to move inside this complexity. Now let's go to the future. Let's go to the dream of synthetic biology. One of the big dreams is to create a pure, complete industries. We're in science fiction now. Okay, and we have just 5 minutes. That's what? Not even. Okay, so very quickly. So the project of living cities with biological house. You make growing your house. That's an idea, which is really working in the imagination of synthetic biologists. I stole this image from the MIT Open BODYWARE website, which is one of the big websites on the web. So I will go here. So, right now, a few words by Freeman Dyson. Freeman Dyson is a well-known astrophysicist, but he's also a commentator of science and technology in America. He's also the father of two big gurus of the digital thoughts, which are Esther Dyson and George Dyson. And he says that, I let you read it, he imagined a little like creatures that, in fact, people down to kindergarten age of children will create some form of life in some, in a few years, their new dinosaurs and so on. This is one of the examples. Another example coming from Georgia Church, I spoke about him a few minutes ago, it's the project of de-extinction. Perhaps you heard about it. It's about resurrecting all the disappeared creatures from the past. So the mammoths, dodo. I didn't look at passenger pigeon that disappeared. And not the dinosaur, because I think the dinosaur is too old and you cannot recognize the DNA. But even Neanderthal man. And perhaps you heard about it because there was a buzz with Georgia Church a few months ago, because he was rumored to have said that he was seeking a woman to be pregnant with a Neanderthal child. After he said that it was an interview with a German magazine and they didn't understand what he said, it was badly translated, etc. He never said that. But he could have said it.
He received thousands. He received thousands.
That's so surprising. So I will close by this last work from Freeman Dyson, which is really almost frightening. And it's about the future of biotechnology. He says that we are moving rapidly in the post-Darwinian era. You know that, in fact, the Darwinian era is quite short in the history of life. Because before Darwin, there was bacteria, and there is always bacteria. And they don't use the sex, death, and reproduction thing because they just clone themselves. And he says that with biotechnology, everybody will be able to make horizontal transfer of genes, and there is only one big species which will, on Earth and perhaps outside Earth, because everybody will be able to exchange genes from every species. It's very, very far-fetched, of course, but it's an example of the way you can imagine a very, very far future of biotechnology. Thank you very much.